Part 2 of modeling with quadratic functions. Yesterday we made it close to, or maybe part way through, the first example, so we'll go back and look at that again. Alright, so in the problem, Chris stands on the edge of a building at a height of 60 feet and throws a ball upward with an initial velocity of 68 feet per second. This is what's happening in that problem. Here's a building, and Chris is standing on a ledge. There he is, and he's at a height of 60 feet. He is going to throw a ball. That ball will go up, reach a maximum height, and then come back down and hit the ground. We have to find all of the important pieces of information to answer this problem, such as how long did it take him to reach the maximum height? What is the maximum height? How long did it take the ball to reach the ground? Alright, what is the maximum height reached by the ball? After how many seconds will the ball reach the maximum height, and how long will it take the ball to reach the ground? We just went over that. So what units are we using to solve the problem? Feet. Easy question to answer. And what information from the contextual description do we need to use in the function equation? Well, the first question we answered was feet. Does that tell us which function we have to use? Didn't we go over yesterday what the two types of functions are? We had two different h of t functions, one with feet, one with meters. The one with feet starts out with what number? After you simplify it. Negative 16. T squared. And what was the middle term? It's 68 feet per second because the middle term is velocity times time. So we will have plus 68 t, and the 68 comes from up there. Initial velocity of 68 feet per second. And then what is the last thing that we have to put in? 60 feet for the initial height. So we know that the problem is in feet. That's why we chose the function that has the negative 16 on the front of it. And then 68t, that's the initial velocity times time, and then 60 is the initial height. Alright, so we have our function, so we can come down here and recopy that onto this notebook paper. Hopefully this will be somewhat neat. H of t equals negative 16t squared plus 68t, and then plus 60. What operation do we do on this function that's going to give us all the answers, or most of them, that we need? Completing the square. So we'll come down here with the red marker, and we have to group what two terms first? That's right, the first two. And since we have an item other than a positive 1 here, what must we do with those two items? Divide them by what? Divide them by negative 16. So we have a negative 16 times, when we divide by negative 16 on the first term, we're left with t squared. When we divide a positive 68 by a negative 16, we come out with a negative answer. So we're going to put in a minus sign, and then just put 68 over 16. And we'll keep the t there. Leave a space, and put plus 60 on the right side. We need half of 68 over 16. When we want half of a fraction, what do we do? Multiply what by 2? We'll have to double the denominator by 2 to come up with 68 over 32. That's going to give us half of that middle fraction. What do we do with the 68 over 32? We have to square that. Alright, so on the calculator, when we square a fraction, do we square the top only, the bottom only, or both? We square both. So 68 squared is 4624 on top, and on the bottom 32 squared is 1024. We have not added just 4624 over 1024 to this function. What we have done is this, negative 16 times this. And since this is negative, this is positive, when you multiply them together you get a negative. So we can consider this to be a subtraction of 16 times this fraction. If we have subtracted, then we have to do what on the outside? We have to add. So over here we're going to go with an addition, and we're going to multiply 16 times that fraction here. When I multiply an integer by a fraction, do I multiply 16 by the top only, the bottom only, or both? The top only. So we come up with 16 times 4624, and that will be 73,984 over 1024. What must I do next in order to finish off this completed square? We don't have to do those fractions yet.
Take out the 68 over 16t and take the half of that and take out the 68 over 16.
Sounds like we're doing this. Tell me if I'm wrong. Negative 16, quantity, use the variable, the sign from the middle, and half of the middle term, which would be 68 over 32. Close it and square. Is that what you're talking about? And then with this out here, we can simplify that. We can do 73,984 divided by 1024. Get an answer for that and add 60 to that and come up with plus 132.25. What can I simplify still that's going to help us out in this problem? The fraction, yeah. 68 divided by 32 is going to come out to be 2.13 when we round. So we'll keep everything else the same and make it 2.13 here. And we have our constant out here on the right. Now that we have this in completed square form, can we find out what the vertex is? Okay, what is the vertex? .3 or 2.13 and then 132.25. We have to figure out what each means though, because it's of no use to us if we don't understand what it represents. What does 2.13 represent? It's time. Time in what units? Seconds. What does this represent? Height in what units? Feet. Okay, so if we want to answer some questions, then how long did it take the ball to reach its maximum height? 2.13 seconds. Time to reach maximum height is 2.13 seconds. And what is the maximum height? 132.25 feet. Okay, and then another one is time to reach the ground. How long after he threw it did it take the ball to reach the ground? Look at the drawing that we had up here. If I can find it. There it is. Look at the drawing. He's throwing the ball. It shows a quadratic graph. It starts at 60 feet, but this graph, in reality, or in theory, would come back down here. What is this on graph paper, the red line that I'm coloring in now? It's the x-axis, and when a quadratic graph crosses the x-axis like that, what do those points represent? Solution, yeah, these solutions, plural actually, of that function. We're going to get two answers back from the answer of a quadratic function. So if we come back down here to the notebook paper, and we'll start on a new sheet. Here is the function that we had, h of t equals negative 16t squared plus 68t plus 60. This is why we did the quadratic formula when we did, because we're going to need it from there up to now and beyond. Okay, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. And that was a question on your quiz today before we got started. What is on the bottom of the quadratic formula? 2a. We have to figure out what a is. A is what in that function? Negative 16. B is what? 68. And C is 60. So we have to plug in that information and come up with a negative 68 plus or minus the square root of 68 squared minus 4 times negative 16 times 60. All of that is going to be over 2 times a negative 16. We're going to do negative 68 plus or minus, but then we're going to figure out what is going to be the result of this. On the bottom, we already know that's a negative 32. So let's do 68 squared. And that's 4624. Look at the middle. It's minus and then a negative. Minus a negative converts to what sign? Positive, so it'll be plus. So we want 68 squared plus whatever 4 times 16 times 60 is going to be. And that comes out to be, under the square root sign, we have 8464. We can simplify that a little bit by finding the square root of 8464. And what is the square root of 8464? 92. So now we have negative 68 plus or minus 92 over negative 32. And we have those two problems to do in order to figure out what the two answers will be. Alright, so we have negative 68 plus 92, and then divide that by negative 32. Then we have negative 68 minus 92, and divide by a negative 32. For the top one, negative 68 plus 92, and then divide by negative 32 is going to give me a negative 0.75. Now, would that make any sense in terms of the time it took the ball to hit the ground? No, it wouldn't make any sense. So we know that that's not the answer we need. Likely it's going to be the other one. So negative 68 minus 92, and then divide by a negative 32. That comes out to be 5. That's the one we're going to need. That means that the ball took 5 seconds to hit the ground. We have to graph the function of the height h of the ball in feet to the time in seconds. Okay, so we're going to go over here and make this axis seconds, and this one over here is going to be height. And I can bold in the axes if I can draw straight enough. So we'll go there and there. What was our vertex?
113 and 1.
That's right. So we have to go over 2.13 on the x-axis and then up 132.25. And then at what time did the ball hit the ground? 5 seconds. So we know that as far as we have to go to the right would have to be 5. So I think we might have enough room to skip 2 blocks. There's 1, 2, 3, 4, 5. And these will be the seconds. 1, 2, 3, 4, 5. And we know that an important point already is 5 seconds here hitting the ground. Another important point is that we know it had a height of 60 feet when the ball was thrown. And we know we have to go up to 132.25 feet. So let's see how we can mark this off. Maybe we can go in terms of, I don't know. Let's see, we have 1, we'll count these off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I think we can go every block equals how much? 10 feet, yeah. So 1, 2, 3, 4, 5, there's 50. 6, 7, 8, 9, 10, there's 100. 11, 12, 13, there's 130. The ball was thrown at 60 feet. So here it is. No time had passed when the ball was thrown. That's the ball being thrown at 60 feet. The ball reached its maximum height at 2.13 seconds. So we're going to come over here at 2.13 and go straight up. I'm going to try to find my line tool and dump something in here. There we go. 2.13 is approximately there. And then with another line, I'm going to do this. Here's 100 and, let's see, that was 100 feet. 10, 20, there's 130 feet. 132.25, we'll say, is approximately there. So there is the vertex. And you should label these off accordingly. That's 2.13 and then 132.25. Down here is 5, 0. Put them in parentheses. Over here is 0, 60. Now we should have enough to come up with some kind of a graph for this. So the ball is thrown, comes back down, goes through there. Here's another example. A theater decided to sell special event tickets at $10 per ticket to benefit a local charity. The theater can seat up to 1,000 people. And the manager of the theater expects to be able to sell all 1,000 seats for the event. So if he sold them for $10 a ticket, how much money would he make? $10,000. To maximize the revenue for this event, a research company volunteered to do a survey to find out whether the price of the ticket could be increased without losing revenue. How much are people willing to pay, in other words? The results showed that for each $1 increase in ticket price, 20 fewer tickets would be sold. Every time you raise the price by $1, you can expect to sell 20 fewer tickets. So here's the first part of the problem. Let X represent the number of $1 price per ticket increases. That's your very first thing. X equals the number of $1 price per ticket increases. The number of times we're increasing the price of the ticket by $1. So write an expression to represent the expected price for each ticket. So X equals the number of $1 price increases. And here is our expression for the price of a ticket. We start at $10. X is the number of $1 price increases, so it only makes sense to have $1 out beside that. Now, of course, you could simplify that and do away with the 1, but we put it in there to start with. And we have 10 plus X to finish with. So we put it in, then we took it out. So B is to do the following. Use the survey results to write an expression representing the possible number of tickets sold. Okay, so how many did they have to start with so far? How many seats are in the venue? There are 1,000. And what's happening every time we raise the price of a ticket by $1? You lose 20 people. That's how many less people you can expect to have buy a ticket. So we have to write an expression representing the possible number of tickets sold. So tickets would be 1,000 minus 20 fewer each time we raise the price of a ticket by $1. We start with 1,000 seats, but we're going to lose 20 every time we raise the price of a ticket by $1. So that's why the X is in there. 1,000 minus 20 times the number of times the price is raised by $1. Using, and I'll zoom in so you can see it, using X as the number of $1 price increases, which is what we've been doing, and the expression representing price per ticket, write the function R to represent the total revenue in terms of the number of $1 ticket price increases. Okay, so first of all you have to understand R for revenue. Revenue is how much money we're going to make. If I had 5 donuts and I wanted to sell them at $5 each, how much money would I make if I sold all of them? $25. So it is the amount that you have times the price per item. And that's no different than what we're doing here. It's going to be the price times the number of items. And in this case, the number of tickets. But remember, we had an expression for the price. What was our expression for the price? 10 plus X. And then we just came up with an expression for the number of tickets. And it is 1,000 minus 20X. Of course, you would have to put this as a function R of the number of $1 ticket increases. So revenue equals tickets times price with an extra parenthesis there. And we have T equals 1,000 minus 20X. So there is our function. R of X equals 10 plus X, closed quantity, times the quantity of 1,000 minus 20X. So remember, we're trying to find what's the most amount of money that we can make in terms of tickets and price. What's the most amount of money that we can make? It's not 10,000, because if we raise the price up from $10 per ticket, then we could sell tickets for 13, 15, whatever. We're trying to find that maximum price that we can sell tickets for and still make the maximum amount of money before people quit buying tickets because it's too expensive. It's going to go like this. We start at $10 and we keep raising the price of the ticket, increasing our revenue, but at some point the public will not buy tickets. When it starts to get too expensive, fewer and fewer people will buy tickets. We're starting at $10, and of course you make it all the way out here. It's hard telling what that price is, but we can find it. But we have to make a quadratic function out of this. We have to multiply these two items together in the function. Alright, so if we multiply those two expressions together, we have to go all the way back to the FOIL method. When you multiply two quantities together, you start with 10 and multiply it by 1,000. That is where 10,000 comes from. Then you stay with the 10 and multiply it by the minus 20x. That's where the minus 200x comes from. Once you are finished with the 10, you go to the x and multiply it by the 1,000. That's where the 1,000x comes from. And staying with the x, you multiply it by the minus 20x. That's where the minus 20x squared comes from. You have to add like terms next. If we add the like terms here of minus 200x and 1000x, you come up with 800x. So now this is really starting to resemble a quadratic function in its regular form, but we're just one step away from that. Where does the squared variable usually end up in a quadratic function? In the front, yeah. So we're going to have to trade places here. We're going to have to move this out to the front and then this out to the back to make it look like something that we can use and get information from. So there it is. All we did was trade places with these two. So negative 20x squared plus 800x plus 10,000. Now, with that, we can do what to that function in order to find the maximum point at which we're going to make the most money? Completing the square, right. So we're going to have to complete the square on this. We're going to complete the square on this new page here, and we have to group these two terms together, just like always. And when we do that, it looks like that. What do we have to take out of the parentheses? The negative 20. So if we take out the negative 20, we're going to have this. Remember that negative 20x squared divided by negative 20 leaves us with x squared. 800 divided by negative 20 is going to give us a minus 40x in the middle. Positive divided by negative, that's where we get this minus sign. We need half of the middle term. Half of 40 is what? 20, and if we square 20, what do we get? 400, right. But look what's happened here. We've added 400 in the parentheses, but that's not what we've really added to the function. We've added negative 20 times 400. That's minus 8,000, so we've really subtracted 8,000. That's why we have to add 8,000 out here on the right-hand side. Once we get to that point, we're going to have to simplify some stuff. So here's what we've done. We've used the variable, the sign from the middle, half of the middle term, squared that quantity. We left the negative 20 where it's at, and we've added this to come up with 18,000. Can you look at that completed square form and tell me how many ticket price increases we can expect to make? Well, can you tell me what the vertex is? And 18,000, right. Okay, what does the 20 represent? Yes, the number of ticket increases for the price. $1 ticket increases. What's the maximum amount of money I can expect to make by raising that ticket price up? $18,000, right, the max amount of money.